In this video, we will cover adding and subtracting vectors. Two vectors can be added together by placing them tip to tail. They give a single or resultant vector, which is the third side of a triangle, hence the triangle law of addition. Notice that vector AB plus BC equals AC, where AC is the third side of the triangle. Also notice that vector A joins the tail of vector B. This shows that we are adding the two vectors to get the resultant vector A plus B. Also notice when we're describing vectors such as vector AB, we have an arrow on top. This arrow shows we are leaving point A and going to point B. We also have the parallelogram law of addition. Because both vectors leave the same point but in different directions, we use the parallelogram law of addition. Notice that vector A plus vector B has a resultant vector A plus B, which is the diagonal of the parallelogram. We can also use the triangle law for subtracting vectors. Remember, a negative vector is in the opposite direction to the original. In our case, we have vector B and the opposite is in the opposite direction, negative B. And it works in a similar way. Vector A joins the tail of negative vector B and to form A minus B. Adding a vector to its negative always gives a zero vector. You can also use the parallelogram law for subtracting vectors. We will now answer some questions. On the screen you can see the parallelogram A, B, C, D, and we need to write the vector that is given in A and B. We are looking at vector AB. Remember, the arrow tells us which direction the vector is going. So we're going from A to B. We also are plussing on BC, going from B to C. In this case, we can use the triangle law. Because the arrow of tail of AB is joining the tail of BC, we know it will be our diagonal, the third side of the triangle, which will give us vector AB plus BC equals vector AC going from A to C. We can do the same for part B. We'll start by highlighting our vectors and which direction they're going in. We have vector AD going from A to D. We then have vector DB going from D to B. Again, we can use the triangle law. We know it'll be the third side. We can then write our statement. So vector AD plus vector DB results in vector AB going from A to B. Below we have a triangle and we need to write vector C in terms of A and B. Because vector A and vector B are going in opposite directions, we can't use the triangle rule at this stage. We do know that the opposite of vector B will go this way, which will give a negative. We then have the head of negative B vector joining the tail of vector A. So we can redraw the triangle, vector A, vector B, and we know our third line will be this one, which is vector C. Now that we have a triangle we can use, I can write them in terms. I know that vector C is going to be negative B vector adding on to vector A. To end the video, we'll do a quick recap. Remember, two vectors can be added together by placing them tip to tail, and they give the single or resultant vector. And we have two laws. We have the law of addition for a triangle and the parallelogram law of addition. They both work similar to subtraction as well. The key here is to look for where the arrow heads are pointing, and if they're joining the tail of another vector, you usually can form a triangle or a parallelogram.